The velocity triangle of Kaplan turbine. This is again very important topic for understanding the design of coupling turbine. So before going into the construction of velocity triangle, let's understand some important velocity terms. These are the inlet and this is outlet velocity terms. Inlet velocity terms are inlet mean runner blade tip velocity u2. Inlet mean relative velocity is v2, inlet mean absolute velocity is c2, inlet mean whirl velocity is cw2, inlet mean axial velocity is ca2, inlet mean blade angle with respect to axial is beta 2, inlet mean absolute velocity angle with respect to axial is theta 2. Outlet velocity component, outlet mean runner blade tip velocity is u3, outlet mean relative velocity is v3, outlet mean absolute velocity is v3, outlet mean whirl velocity is cw3, outlet mean axial velocity is ca3, outlet mean blade angle with respect to axial is beta 3, outlet mean absolute velocity angle with respect to axial is theta 3. Unit of all above velocity are in meter per second and unit of blade angle is in degree. So coupling turbine is a axial inlet and axial outlet is a pure reaction turbine, and this is a typical diagram of coupling blade. This is runner, this is blade, and these are other views. So inlet mean absolute velocity c2. Now let's start the construction of velocity triangle. So draw the inlet mean absolute velocity, that is a c2, which is axial direction, which is perpendicular. This is axial, so this is axial, and again this is perpendicular to the direction of rotation of the blade. This is direction of rotation of blade, and this is the inlet mean absolute velocity, which is axial. Inlet mean runner blade tip velocity is v2, so you need to draw the inlet mean runner blade tip velocity as shown in the same direction as the direction rotation of the blade, and it depends on the speed and runner blade mean diameter of runner at inlet, which is expressed as u2 is equal to pi d2m into n upon 60 into 1000. So this is value through which we can calculate u2. Inlet mean relative velocity v2. Draw the again or join the this thing starting point of c2 and the starting point of u2. You will get the inlet mean relative velocity, that is v2. Inlet mean whirl velocity cw2. The tangential component of inlet mean absolute velocity is called the inlet mean whirl velocity, but the tangential component is 0, so cw2 is 0. Inlet mean axial velocity ca2. That axial component of inlet mean absolute velocity is called the inlet mean axial velocity. So in this case, axial velocity inlet mean axial velocity is equal to inlet mean absolute velocity, that is ca2 is equal to c2. You can see here, and inlet blade angle beta 2 is shown here, which is measured from the axial direction. Outlet mean relative velocity, that is v3. So draw the outlet mean velocity outlet mean velocity, outlet mean relative velocity v3, and draw the v3 in the same direction as the outlet blade angle, that is beta 3. And so as this is a reaction turbine, so v3 will be certainly greater than v2, because the v3 is greater, velocity is higher, because there is a drop in the pressure and a cross-section area at outlet is smaller than this. Outlet mean runner blade tip velocity, that is u3, and u3 you have to draw the u3 in the same direction as the direction of rotation of the runner, and its magnitude depends on the speed and mean diameter of blade at runner blade at outlet, and which is expressed as U3 is equal to pi d3m into n upon 60 into 1000. D3m is mean diameter or at of blade at outlet. Now outlet mean absolute velocity, that is C3. So you have to join the starting point of V3 and end point of U3. You will get the C3, that is outlet mean absolute velocity, and outlet mean whirl velocity CW3. So tangential component of outlet mean absolute velocity, this one, you will get the outlet mean whirl velocity, that is CW3, and axial component of the outlet mean absolute velocity is called outlet mean axial velocity, that is CA3, and this theta is shown as outlet mean absolute velocity. So this is how we can draw the inlet velocity triangle and outlet velocity triangle. Please note that the flow at inlet and outlet both are axial for Kaplan turbine. So hope you enjoy this. Thank you. Thank you for watching.